Hello, my name is Leon Johnson III,
I'm Blake Mazurowski.
and we will be presenting on the perfect cup of coffee. Okay, first I will be presenting our parameters. This is Newton's law of cooling, in which T prime is the change of temperature, which equals K, which is the constant unique to the solution, times A minus T, which is the ambient temperature minus the temperature of the coffee. I will then go on to part 2, which is us solving the equation. We first started with the separable method, and using the separable method, we solved until we got to T equals A minus CE to the KT. We then, using those conditions, solved for when the coffee, when it first came out, it was 200 degrees Fahrenheit. Then after 5 minutes, it was 180 degrees Fahrenheit. And using these initial conditions, we were able to find the constant K, which is the constant which is unique to the coffee. So then we used that factor in all of the problems, which we then used the integrating factor method to solve it. Then used the characteristic method with methods of undetermined coefficients. Then used the Laplace transform method to solve. And there's all of those for you. I will then be passing the mic to Blake Mazurowski to talk about the rest.
Hi, so I'm Blake Mazurowski, and I'll be going over the rest of our problem. So I'll move on to part 3, which is solving the cooling problem. So as you saw earlier, we have our solved form of Newton's cooling law, which is the ambient temperature of 70 degrees Fahrenheit plus 130 e to the negative 0.033 so on t, that constant that we solved for. And we found out that at t equals 140 degrees Fahrenheit, about 18 and a half minutes had gone by. And when the temperature of the coffee was 120 degrees Fahrenheit, about 28 and a half minutes had gone by. So subtracting the large one from the smaller one, you can find out that you have about 10 minutes and 4 seconds to enjoy your coffee at that deemed perfect temperature. So now we're going to move on to the variable problem. So let's picture this situation. You just made a cup of coffee and it came out at 200 degrees Fahrenheit, and you're in your house at a nice warm 70 degrees Fahrenheit. So the coffee will cool in that temperature, and then at about 5 minutes after making that cup of coffee, you walk outside, and it's a brisk day like today, where it's a nice 50 degrees Fahrenheit outside, and starts to cool a little faster. So we were able to model that using the unit step function. So we have this new form of the temperature right here, which includes this unit step part at 5 minutes. And so using those same things, we solved for when the temperature of the coffee was 140 degrees, and that was about 16 minutes. And then we solved for when the temperature was about 120 degrees Fahrenheit, which was at 23 and a half minutes. So using the same thing as last time, we subtracted it and found out that you have about 7 minutes and 31 seconds to enjoy your cup of coffee at the perfect temperature. Whereas before, if you didn't walk outside at that 5 minute mark, you had about 10 and 4 seconds. So it makes a pretty big difference just from walking outside for a little bit of time. So yep, that's our presentation. Thank you.
Thank you.